The particle moves along the x-axis, and at t equals 0 the velocity is 14. Since it's decelerating at 4 meters per second squared, the particle is going to slow down to a stop and turn back the other way and accelerate towards a negative x direction. So you can see it passes 22.5 two times, giving us our t1 and t2. Now the way you actually calculate these is with just simple SUVAT. Use s equals ut plus half at squared, and that will give you a quadratic in t, and you'll get your two solutions for your times, which is 2.5 and 4.5, so the difference in times is 2 seconds. So for part B, we want to find the distance travelled between t1 and t2. Or in other words, the length of that cyan line and the length of that magenta line. Now there's two ways we can calculate that. The first way leads on from our previous answer, where we know the difference in time is 2 seconds, so the time it takes for it to stop will be half that time. So it's going to take 1 second for our v to equal 0, because that's where the particle stops and turns around. So we know what a is and we're trying to find out s. So we can use s equals vt minus half at squared, plug it in and you'll get s is 2. But since it travels 2 meters towards that point and 2 meters back, it travels a total of 4 meters. Another way you can calculate it is actually finding the distance at the point which the particle stops. So at that point, v equals 0, we're trying to find out what s is. We know the initial velocity is going to be 14, acceleration is minus 4, and t we don't care about. So we can use v squared equals u squared plus 2as. Plug in the values, rearrange for s, you get 24.5. Now you can work out the distance between 22.5 and 24.5, which is 2. Since it travels 2 meters towards it and 2 meters back, the total distance is 4 meters.